Good day, everybody. Welcome back to the channel. I've had an allure and attraction to this idea for years, but it's not unique. Other people have done it. Other people have done variations on it. It's the idea of the pixelated photographs, pixelated images, done strictly using optical means. And I'm going to show you a series of examples of other people who have done this kind of a project, but I started on it sometime probably back about 2013 when I was more active in the F295 pinhole photography discussion forum. Recently, I kind of introduced my friend Ethan Moses to this idea. We kind of got down into the rabbit hole of how can we 3D print or laser cut some kind of a camera device using this kind of principle. And last week I had a great opportunity to spend some time with Ethan where we went down the rabbit hole once more of kind of building a little camera device using the principle. But more recently I've also been working on some just empirical calculations and kind of sketches on how this device works. I'd like to share all this with you today. Stay tuned. Ethan is in SolidWorks working on this design of our grid camera.
Yeah, I'm excited about it. I think we figured something out without having to do the math. SolidWorks did it for us.
Yes. Well, when I was first working on this pixelator idea, it came across the idea of a grid in back of the camera right in front of the film plane, and there would be a translucent screen right in front of that grid that either a lens or a pinhole or a larger hole would project an image onto that screen, and then the grid would sort of average out the light image on each pixel, each square of the grid to make a pixelated image. I built several cameras based on this principle. This was the little F50 pixelator using cardboard construction. I made this whole camera, even the grid, from strips of cardboard put together, and there's the hole in the front. It's about 1/8 of an inch diameter, so it makes about a 20 by 20 pixelated image there. And then I went to a larger size camera, and it uses a kind of flip up shutter like that, and the size of the pinhole, or it's not really a pinhole anymore, it's probably about a little over 1/8 of an inch. The back of it is using a commercially made or commercially bought plastic sewing mesh. So these have roughly 8 squares to the inch, and because of the time it took me to build this cardboard grid by hand, I wanted something pre-made. So what I did is I taped a sheet of wax paper to the front side of this mesh with some black vinyl tape, and it serves as a view screen, a projection screen from the hole in the front of the camera, and then each little hole in the mesh becomes a pixel. Whatever image is projected into each square, it gets sort of averaged out as some average gray scale of light by the time it hits the film on the back. And that was essentially the principle of both of these kind of pixelator cameras. And that's when I ended up building this camera. So at the back of this device is an opening for a piece of photo paper that's roughly 4 inches square. So the back of the camera is the tail end of this conical cluster of black plastic coffee stir sticks, and they form a tight cluster of round, roughly round pixels. And the idea of this camera is the diverging angle of the tubes from the front to the back directs a particular narrow angle of view from each tube into its own pixel spot in the back, which is averaged out, that light is averaged out into some intermediate level of exposure at that point. And so you have this kind of an angle of view of the camera, right, looking outwards, producing this relatively small, low-resolution image. I don't remember, maybe about 30 by 30 roughly, something like that, and not a super high-resolution image. But it's just a different principle from using the pixelator grid at the back of the film plane with a diffusion screen and a grid behind it. So this is a build photo of the first prototype of the pixelator. You can see the rear screen uses one of those sewing meshes to anchor the rear ends of the coffee stir sticks together. And then this is the front end of the first prototype, and this is the first prototype. Looking through it, you can see a little bit of light coming through from in front of it. And then the second prototype, the larger one, This is one of the build photos before I started putting the coffee stir sticks in place. And here is a shot with just the central portion with stir sticks in, and you can almost see an image through those sticks. The way they tend to form an image from behind, it almost looks refracted. And then when this camera, the second camera, was partly completed, I set it up with a makeshift ground glass view screen behind it, and I took a digital photo, several digital photos from that screen. I was seated right in front of the array of tubes, and I was brightly lit. So here's a sort of a self-portrait that I kind of like. It's very interesting colors, and if you get back away from it enough, it does look quite interesting. This is probably not what you want to do for this winter as a project, is making this into a camera. I did spend the greater part of one winter building this prototype camera that never worked. But here, anyway, here's a bag of thousands of coffee stir sticks that I'm never going to use.
Yeah, so we basically designed a box, right, around 4x5 film. This is 120 millimeters, and it set an angle of view. And then we created a variable center plane here with the center pinhole that had variable focal distance and then also variable size. And then we set pinhole spacing here. And then we set spot size and spot spacing on the film plane, and then allowed SolidWorks to solve for where, in terms of front and back, the pinhole was located and the size of the pinhole. Basically what we got was a 1.5 millimeter pinhole spaced every 1.5 millimeters would yield we set it to a 2.9 millimeter spot with 0.1 millimeter spacing, so almost touching, right? They'll probably touch with diffraction. Yields a pinhole at the center, a central aperture of 0.8, which I think I have a very close to 0.8 millimeter drill bit. We also get a aperture spacing of 57.8 millimeters in front of the film plane, and 59.8 millimeters behind the. And
it's almost a 60-degree angle of view.
Yeah, we gave it a 54-degree angle of view.
Very cool. So you're gonna draw out a file that we can go cut, right?
Well, so like maybe just like a cap that we tape for prototype purposes.
Well, we're down here at Q-Lab in downtown Albuquerque, and Ethan's going to set up the laser cutter to cut some acrylic plastic, black acrylic plastic, to put together a prototype of this Pixelator grid camera in 4x5 format. And it's going to be a real simple camera with, you just load up single sheets of paper. It won't take film holders. It's going to have a pull shutter, and then the grid will be in the front. And we're going to try laser cutting the grid out of thick black craft paper. Well, about the same time it took me to cut out those 4 squares of black paper, the laser cutter cut all of our acrylic pieces. So my job is to peel off all the paper backing. Yay! There's probably a trick to this. Gotta hold your mouth just right.
I'm down to just melt the whole thing together. Slosh around some
sloppy and dirty.
Some real
prototype.
Yeah, real gross chemicals.
Use it together and let it dry, right?
Yeah. Yeah, I suppose the way we built this, it should have some light leaks, but we got plenty of tape. Yeah.
Well, okay, so Ethan is loading up our first test sheet of paper in the camera right now in the darkroom. So we're going to go outside and try to find some kind of a scene.
Set timer for 45 seconds.
Your timer is set for 45 seconds.
Nice.
Okay.
All right.
Okay.
Yeah. Now move it in closer to the lens. And now it becomes, now it kind of disappears.
Yeah.
Isn't that amazing?
I think we should shoot a portrait with this thing.
Yeah, so that was 45 seconds.
45 seconds. It looks about right in direct sunlight.
Yeah. Okay. F200.
Yeah, I'm going to throw this back in the fixer.
Okay. Okay, so the first test image was just a landscape shot looking out the QLab space into the north-facing parking lot. So you have the sky up here and then some of the landscape and probably the edge of the street right here. These are, of course, paper negatives, so the tones are inverted. Dark is where there was a lot of light. White paper is where there's very little exposure, very little light. So obviously they're negatives. And then the second one we did was a shot of myself, and this camera is fairly wide angle, by the way, so this is about 120 degree, roughly, something like that, angle of view, so you can see my head and torso in the sky behind me, right? So and it was only a couple feet away from me, so a pretty wide angle camera. And then I got up a lot closer to the camera, and there you can probably see me a lot easier. And so my sketch journal, dated November 2nd, is when I first documented this idea of the Pixelator camera using a front of the camera with a aperture grill, a mask of apertures, a center or middle mask, and then each one of these front apertures gets projected to its own spot at the film plane, which would simulate the effect of having a whole cluster of tubes without actually having to use tubes. So I began to study this design a little bit more with these crude sketches where I was only showing several of the holes at the front of the camera. And I started off with putting the rear aperture midway between the lens board or the aperture grill and the film plane in the back. And you can see with just simple ray tracing here that you have, in this particular design, based on the sizes of the holes and the spacing, you have some overlap of the image circles at the film plane, right, which is not really ideal. And then if you shrink down the middle aperture, the rear aperture, small enough, you'll get a point where you might get the images to be right adjacent to each other with very little overlap. And then you can also use longer camera designs such as this idea here, where you may still have some overlap or not, depending on where you put this central rear aperture and what the size is. So again, here's another diagram showing a whole grid of apertures in the front, and I've shown just the centers of the light bundles coming through the center aperture. So you can kind of see how it projects an image here. And one thing that's kind of interesting, though, with this particular design where you're putting the rear aperture in the midway point between the front and the back is the overall angle of view of the camera is like this, in this case. Whereas if you had a single pinhole camera of the same length, like right here, it would have an angle of view that's tighter, right? So that angle of view would be if you had just a single pinhole, but this one, it assumes the angle of view as if the pinhole were back here at the midway point. So it makes a wider angle of view than you might expect. The front focal distance from the aperture plate to the middle aperture is the same as the back distance. So this diaphragm is in the midway point, and with a very large size hole so you can really see it easily. So I have the same size hole in the rear aperture as I'm using in the front aperture, and you might be able to tell just graphically that the spot size, which I call I1 or image 1, spot size at the film plane is 3 times the diameter of the actual aperture hole itself. And then I asked myself, well, what would the parameters of the camera have to be in order to get the rear image size to be the same as the front hole size? And if the rear diaphragm is midway between the front and the rear, the fact of the matter is it would be impossible to make, because you would have to have the rear diaphragm stop down to 0 size. That means under these conditions you can't do it, but what about moving this aperture bulkhead further back or forward? How would that affect it? And that proved to be rather interesting. So what I did here is I drew a general diagram where I have the front aperture size is called A1, the rear aperture size is called A2, and then the front distance is called F1 and the rear distance is called F2. And in this particular example, I'm saying that the A1 and A2 aperture sizes are remaining the same, and so this is sort of a special formula for A1 and A2 apertures are the same. This formula works, but then I decided to make a more general formula for any combination of apertures and of any position of this rear dividing bulkhead. So in this more general formula, A1 and A2 are not the same. F1 and F2 are not the same necessarily. I'm calling the overall image size at the film plane, it's going to be A2 plus this spread, just two of these spreads, S2, right here. And when you run that formula in together with the previous formula, you end up with this particular general case. So the spot size at the film plane is related to this right here. It's basically related to the ratios of those focal distances and A1 and A2. So in the case of F1 and F2 are the same, and A1 and A2 are the same, the formula works out that I is equal to 3A, which does work out graphically if you actually draw it out accurately, either on paper or in drafting software, CAD software. You'll see that's the case. So having that formula at hand, I wanted to create a special case to where the spot size I1 is the same size as the front aperture A1. And I worked through the formula backwards and ended up with this condition here where basically F1 focal length is 3 times F2, right? So the bulkhead back here is 3/4 of the way back toward the rear, and the hole size A2 is half of the hole size A1. And under those conditions, if you space the front holes with a gap of equal to 2A, 2 size the hole size spacing between each hole, under all those conditions together, you end up with spots at the film plane that are the same size as the holes up front, and they don't have any gap between them. They touch or they abut one onto the other. So this particular special case will satisfy all those conditions. However, the thing you might notice is up here, the spread of these two holes, if you compare that to the image size is going to be half of the array size. So in other words, if you desire to have a 4 by 5 inch image, you're going to have to use an 8 by 10 inch array of pinholes, of aperture holes up front in order to satisfy that condition. So there's one tool that I found is actually quite handy for pre-visualizing the pixelated image at the back of the camera here, and that is if you use regular Scotch tape, so-called Scotch tape, right? This kind of semi-translucent frosted tape that you use in your desk at home or at work. You put a piece of that across the film plane. This stuff works as a really good ground glass. All right, so I'm just pointing the camera up at one of my video lights here, and you can probably see pretty well the pixelated holes here, and you can also see right near, where's my finger right there, and the edge of my image is cut off a little bit by the mounting system in the front of the camera. Let me move my finger out of the way. You can see the image goes about that far left to right, but there it is. Yeah, you can pretty much pre-visualize this image pretty easily. And you'll notice from this and from our test negatives that we shot over at Ethan's that our pixel spots don't touch. There's some space between them, and I think we can make that space smaller. So the images that we made last week are interesting, but when you get up close to them, the image kind of falls apart, and one of the reasons might be because the amount of blank space between each pixel at the image. I think when the pixels are further apart, you can't as easily distinguish subtle tonal differences between them, but when they're up close to each other, it's easier for your eyes to distinguish those subtle tonal variations. And so I think what I want to do is just make the pixel spots larger at the film plane, and because the geometry of the camera is fixed, right, the position of the rear aperture is fixed, I think I can just make the rear aperture bigger, and that'll give us a larger spot spot size back here. Well, this was the sun face on the back wall of my backyard, and this is with the, I think it was 0.8 millimeter aperture that Ethan had installed in the rear aperture of the camera. Also, I might have overexposed it a little bit, I'm not really sure, but so the contrast is very low. You can barely make out the image there. So what I wanted to do was to enlarge the rear aperture a little bit to give me pixels at the film plane that were closer to touching. So this is the 0.8 millimeter aperture that Ethan drilled in a piece of aluminum can material with a micro drill bit on a piece of gaffer's tape. So this was the original rear aperture. And this is the second aperture I used. This was roughly 1/8 of an inch, maybe a little bit smaller, crudely drilled into a piece of brass, and it definitely produced pixels on the film plane that were overlapped. Probably about a 15-second exposure, so definitely a different kind of resolution. A lot more easy to see the resolution or the image itself now that the pixels are closer together. And actually, if you notice, the pixels are actually overlapped now. The black grid between the pixels is really overlapping pixels. So we have really too large of an aperture, but we certainly have an image. It's a lot easier to see now. So I think the next thing I want to do is make the rear aperture a little bit smaller. And this is the current aperture that I'm using. Again, it's in a piece of 2 mil thick brass. It's about 1.5 millimeters, and it looks like it's pretty close to the ideal size. And now it's starting to look really interesting. So there is a little grid of black spots in the positive image that's really the corners between the round pixels where they don't actually overlap. The image is very recognizable, quite good, really amazing. I think this is probably one of the best images I've gotten off of any kind of a Pixelator camera. So quite interesting, and I like the subtle shadow details on the back wall around this little figure. So I wanted to include this image just to show you what this was a mistake. Yes, even us perfect people make mistakes, haha. So I actually mounted the camera to the tripod backwards, so it's actually pointing at me instead of at the back wall. And so on the left side of the image, you can see the house behind me and some of the sky. And then on the right side of the image is kind of probably my torso, my shoulders, and whatever, blocking part of the view. But I just thought it was very interesting. Hey, there you go, an accidental rear view shot, you know. So for this image, I went along the south-facing side of my white storage building, which is the large trapezoid area on the right side of the negative there. And I was only maybe 1.5 feet away from the camera, but it's such a wide angle of view that my face isn't really that big or that well defined. But nevertheless, you can definitely make out some features, especially if I reverse it into a positive image. And so this image is a landscape-oriented portrait. I'm closer to the camera, maybe about 1 foot away, and I'm in the front courtyard. And I think the shutter popped open accidentally before I had the camera set, so there's some kind of funky exposure going on the upper part of the image. But nevertheless, there's kind of a recognizable face in the bottom half of the image. And then finally, there's this image. When I finally figured out how to get my camera set in portrait orientation on my tripod, I did this exposure of my wife. This was about a 20-second exposure in kind of cloudy light in the front courtyard, but it's really good. You can see the sky above her head. You can see the courtyard wall behind her, a little bit of a trellis and a window to her left, and then, of course, her face there. So quite interesting image. I'm quite pleased with that. And it's probably worth showing you that the shutter on the inside of the camera here, I have the shutter on the front side, the front half of the camera, just using some scraps of acrylic plastic taped in there with gaffer's tape to make a couple little rails, and the shutter itself is just a T-shaped piece of acrylic that we laser cut. So yeah, just a simple shutter. This particular shutter, though, is so easy to move that it will slide out on its own if you're not careful, and I did have a couple unintended exposures because of that. It's important to point out that I didn't invent the Pixelator idea. I just independently came up with it along with a number of other people, and this led me down the rabbit hole of looking on the internet for other examples of Pixelator cameras and Pixelator arts. So this is a screen grab from a video of Jason Eppink's Pixelator project, and what he did is he did these makeshift pixelator screens that he would put over video screens at the Metro Transit Authority stations in New York City. And what it created was these moving video pixel kind of art installations. Instead of seeing video advertisements and whatever, you just saw this pixelated art. It was an interesting underground kind of guerrilla art using the pixelator effect. I really thought that was very cool. There is a Flickr channel called the Pixelator. So they're roughly 14 by 14, it appears like. Color pixelated images, very abstract, except when you step back from it, it starts looking more like you squint at it a little bit and you can actually see the image. And so there's another example of pixelator imagery in photography and art. So there was a toy craft product called the Smart Pixelator. This is a digital device that puts an image that you can upload to the device onto a screen, and then you put this black mesh in front of it, and you have a whole set of different plastic little beads and plastic tubes that you can stick on there to match the colors. So you can create pixel art, like pixel bead art, using this, and you can also create your own images. Just representative of the idea that the pixel phenomenon is kind of well known, or at least known in popular culture. Here's another pixel-related Flickr channel. This is fellow F295 photographer Howard, whose Flickr handle is We Hammocks, and this is one of the screen grab of a number of different color images that he shot using his drinking straw array imaged with a digital camera. And these are some really beautiful pictures. I really like what he's done here with these. And this was also fellow F295 photographer James Guerin, and he made a drinking straw array for his Holga pinhole camera. And with that, he's been able to do these pixelated images in Holga on film. This is a screen grab from Adrian Hampth's website. He did this very fascinating project using a drinking straw array camera with a Raspberry Pi controlled with a Nintendo controller. So it's kind of a mashup of digital electronics and this, what you might call analog drinking straw array. And he makes these wonderful portraits with it. So people have certainly worked on the pixelator concept in the past. And this is one great example of the kind of work being done. So there's a photographer named Jim Richards, also known as Maker Jim, and he has a website where you can request these straw pixelated camera portraits. And so he has a little point of sales feature on his website where you can actually request such portraits to be made, which is kind of a commercialization of the pixelator phenomenon. And then I want to obviously switch to probably the best example of pixelator art was this project done by Michael Farrell and Cliff Haynes. And they built a number of these wonderful cameras. Here's an example of a hexagonal camera. It's basically just an array of a whole bunch of black coffee stir sticks, kind of like what I had. They're arranged in a hexagonal grid, and then he has a screen on the front. I guess he has a plastic screen in the front, a clear one to hold the straws in place, kind of a equivalent of a ground glass view screen on the back, and then he images or captures the image with a digital camera. But he's using studio lighting, and he has a number of great images, and this, of course, was on a gallery exhibit a number of years ago. This is probably one of the finest examples of pixelator art.
Well, I had some interesting results today from this little prototype camera, and that really is all this is. The resolution is very, very low, 30 by 30 roughly. But I think the neat thing about this idea is it presents a way forward to experiment with pixelator cameras in the future without having to resort to thousands, literally thousands of coffee stir sticks or some other kind of system like that. We can get the same optical kind of effect through a grill, an aperture plate, and another aperture behind it that simulates the effect of discrete tubes. And so I look forward to taking this same design principle and scaling it up. I see larger format cameras in our future here with this. Maybe 20 by 24, maybe RA4 color reversal
prints done in a large format scale. These would be really easy to do, especially if you're laser cutting the aperture holes in the front of the camera. The rest of it is just a simple box. So it's going to be interesting, and look forward to more videos hopefully in the future for this. Well, this is just another of a series of videos about myself dabbling in these oddball, different kinds of image forming cameras, image forming devices, alternatives to conventional lenses. That kind of stuff really interests me, and I hope you found some interest in it yourself. Well, I wish you guys the very best. Stay well, stay happy, stay creative, and if you have any issues, and if you have any questions down below, please drop a note. I'd love to have a dialogue with you. And until next time, you guys stay creative. Bye-bye for now.